Bonjour à toutes et à tous et bienvenue dans cette 10e édition de Parole d'experts. Aujourd'hui, nous avons un invité spécial, un ami, un collègue avec qui nous avons œuvré pendant 20 ans aux États-Unis, en Europe, en France. Donc c'est vraiment un très grand plaisir d'accueillir pour cette conversation Jack Hidary, le CEO de Sandbox. Bonjour Jack.
Bonjour François, merci pour ton invitation.
Jack and we've met I think 18 years ago.
Oh, it's been a while.
And Jack and we were friends and colleagues, and he did a fantastic job for us in the US, bringing new ideas, a lot of energy. So it's my great pleasure to welcome my friend and colleague, Jack Hidary, the CEO of SandboxAQ. So Jack, before we go into artificial intelligence, quantum, tell us a little bit about yourself.
Well, François, first of all, it's great to be here and to be here in Paris. We're doing so much now in France. Across the whole country. I think we'll get a chance to talk about all the activities we have here. But for myself, I started very interested in how the world works. I was interested first in how the brain works. I studied neuroscience. And at the same time, I was also interested in how the underlying architecture of the universe works, and that's physics. And these passions of physics, neuroscience came together. And as that was happening, the computer revolution was emerging. Before even we knew about the web, we started programming, we started coding, and I went to computer camp as a kid, and so I was a very big geek as a kid, learning how to code, and it was very exciting where you could see your own work active on the screen. And so these three different strains of my life, coding and neuroscience, AI, and physics, my dream was always to bring these together and to solve some of the world's biggest problems. The problems of drug discovery, of bringing a new drug to market, the problems of new clean tech innovation, the problems of new materials for our world, the problems of using AI in terms of analyzing, what trends would be in the future. These are all issues that we need all these three different kinds of disciplines to come together. So I was always interested, Francois, to be a cross-disciplinary individual. I was never one wanted to pigeonhole in one place.
You could be French, because, in France, we are famous to have horizontal thinkings,
Yes.
aggregating various things. So tell us about the phone call you received 7 years ago from two famous entrepreneurs.
Well, 7 years ago, I had created a few companies. I was focused on clean energy. I was focused on some philanthropy. And I got word from Google that they were starting something new, something called Alphabet. And they were looking for individuals to advise and start companies and start new divisions within this new entity. And the idea of Alphabet, of course, is that while Google focuses on search and organizing the world's information, there's a lot of other things that computing can do. Self-driving cars already was an idea inside of Google, and they decided to launch Alphabet as a way to house these new ideas. Self-driving cars ended up being the first spin-out, that's Waymo. And of course, one of the next ideas was healthcare information. My friend Andy Conrad started that inside of X initially and then spun out as Verily. So a lot of exciting ideas. And when I joined about 7 years ago, the idea really that we started to talk about with Sergey, myself, Astro, many others started to join in the conversation is how could advanced computing, be it AI, be it quantum, how could that change the game when it comes to society's biggest challenges?
So Jack, tell us a little bit how the spin-off occurred.
So we were building and building different kinds of technologies and realizing that the world was going to change. The GPU in particular, this graphics processing unit, GPU, Alphabet was launching its own GPUs called the TPU, Tensor Processing Unit. NVIDIA, of course, a very strong company, now one of the leaders in the world creating GPUs, and many other companies as well, Amazon and now Microsoft and many others also creating these specialized chips, these chips that would accelerate certain kinds of operations. Initially for graphics. Then people realized, of course, that this was the same kind of operations that we needed for deep learning, for advanced kind of AI. Today, we all hear about large language models, different kinds of deep learning, the graphics of DALL-E 2, DALL-E 3 now just came out. So it's a very exciting moment, and GPUs are core to that. But what we realize in SandboxAQ is that these GPUs can do even more. They can do something very, very special, and that's called simulation. And so AI, very, very important. When you have a lot of data, you could train a deep learning network, a network that's inspired by neuroscience, by the brain's distributed architecture. And so you can train that in the way we train toddlers and children. They look at many examples, they learn from examples. But in addition, there's another very powerful tool, a tool, Francois, simulation, that will become equal in the global lexicon very soon in the next few years to the word LLM or generative AI. And that word is simulation. Simulation means that we don't have a lot of data. We want to create a new drug, a new molecule, a new kind of battery chemistry. We don't have any past data because we're creating something novel. And so to do that, we have to use the first principles of physics itself. We have to say, will this electron from this molecule bind to this electron of this molecule in the body? Will this ion and this ionic structure in a battery chemistry be something that has good energy density? So these are questions that are quantum questions. And now the GPUs got fast enough, we can actually do some of the simulation on the GPU itself, even in advance of the advent of scaled quantum computers. So with this realization, we decided it was time to spin out. And about 18 months ago, we did spin out as SandboxAQ with Eric Schmidt as chairman, myself as CEO, and a wonderful group, a cross-disciplinary group, Francois, of physicists and chemists and AI engineers, really a wonderful group. And the company has really grown since then, particularly because in December of last year, we closed on a round of $500 million. That's from T. Rowe Price, from Guggenheim, from wonderful leaders like Eric and others. And that capital allowed us to become, I don't say global, I say multi-local. A company that has its roots not only in the US, but also in Canada and here in France and Spain and England and many other countries as well, serving those customers and those communities with advanced computing. So it's been a very exciting year and a half, Francois.
So Jack, 4 months after the spin-off, you bought a company in France. Tell us about that.
Well, as we spun off and raised a large amount of capital, we started to hire a lot of people and wonderful people. We also looked, though, for key groups of talent around the world. And again, we took a multi-local view of the world where we want to have deep roots in many parts of the world so that we can serve those customers and also engage with the wonderful talent in those countries. We heard about CryptoSense from several customers of ours. Multiple banks who are customers of ours told us, hey, SandboxAQ, we're going to use your software. It's great for encryption management, but also we're going to use CryptoSense. And so it was a wonderful team that spun out of INRIA, the research organization here in France, a group mainly of PhDs and based in Paris, but with people around France. And we started having conversations with them, but maybe some kind of cooperation, partnership. And quickly, within a few weeks, we all realized this would be a great acquisition for SandboxAQ. And so we did acquire the company. We had to go through some engagement with the French government because, of course, it is national security. And we successfully passed this level of engagement. And so now we have a full subsidiary and a full company here in France. We're very proud to say, yes, that we have very good footprint. In fact, more than 15% of our employees worldwide are here in France. And we're growing that population. France has an additional attraction of the universities in France. The Polytechnique, ENS, many wonderful universities across France that we draw wonderful talent from. And we keep that talent right here in France. The idea is really people should work where they thrive, and they're thriving here. They should work here as well. So it's a very exciting time for us in France.
So you're talking about deep tech. I'm very interested in this world because we talk about this more and more. How would you define deep tech versus traditional VC-based, VC-backed companies?
It's a good question, Francois. So when we look at the history of Silicon Valley, particularly the last, say, 20 years, we saw a lot of investment in productivity tools where you can look at Slack, right, or Jira, or different kinds of group productivity tools. You can look at other VC-backed companies in social media as an example. But deep tech says something different. Deep tech says, we could also call it frontier tech. Frontier tech, deep tech says, let's fundamentally have a leap forward in our society, in the cars that we drive, in perhaps even flying cars, in how we go to space. How can we reduce the cost it takes to get to space, not only to bring crews up there and humans up there, but also for satellites. And we see the big success, of course, of Starlink right now. That's a deep tech innovation. When we look, for example, at the world of medicine, that's a key area for deep tech innovation, both in terms of new pharmaceuticals, but also, of course, diagnostics themselves. I don't mean just diagnostics in a hospital setting. Part of the deep tech revolution is to bring diagnostics to the home and bring it to a ubiquitous setting as well. So when we look at now deep tech as an asset class, what we're finding with investors like T. Rowe Price, like Guggenheim, investors like Jim Breyer of Breyer Capital, Mark Benioff, the founder of Salesforce, Thomas Tull, all these are investors of ours in SandboxAQ, and we're proud to have them because they recognize what we recognize, which is that deep tech actually is less risky in investment because when you make these investments, you're creating a deep moat around this technology, a deep moat of intellectual property, of expertise, of connection with customer. You're making a very, very deep differentiation that's very hard to commoditize. And it also lends itself to platform type companies. What do I mean by platform companies? I mean companies that have a core technology that you can build many different products on. That's a platform company. And that company is going to be far more valuable and more impactful than just a single feature company that might be a good acquisition for some of the big tech companies, but is very different than frontier technology. So while frontier technology maybe 20 years ago, Francois, may have seemed like, wow, that's way out there. Now, the largest asset managers in the world, T. Rowe and many others, the largest family offices in the world, Mark Benioff, Eric Schmidt, Jim Breyer, many others, are recognizing this as its own asset class with a particularly favorable risk-reward ratio because of the connectivity across these different parts of the platform and the ability to defend that platform and build on it for impact in society. Most of our investors, Francois, are here in our company not just for financial return, but for positive impact. And that positive impact is very much there with frontier technology.
So Jack, we're talking a lot about AI, quantum. Not a lot of people knows, what those acronyms means, but I think AI starts with the Turing thing in 1953. I start to talk about quantum, easy known words, and with Einstein and the quantum at the beginning of the 20th century. Could you give us, in your view, a simple definition of quantum, a simple definition of AI, why Sandbox aggregating AI and quantum is ahead of the game?
Yeah, it's a great question. So, there's a lot of buzzwords out there and we throw them all around. And so let's define some of these. It's a great idea. AI, let's start with AI, artificial intelligence. That's a name that came up and was coined in 1955 because a number of people, John McCarthy and others, were applying for a grant from the Ford Foundation, of all places. And they said, we want to have a summer up at Dartmouth, and we want to really focus on this new kind of technology. At that time, actually, it was not called AI, it was called cybernetics. And Norbert Wiener was the one who coined that particular term. But John wanted a new term, and so they called it artificial intelligence. We're kind of a little stuck with that now. We could have called it augmented intelligence. We could have called it synthetic intelligence. There's many other possible names, and so maybe we should still think about some new names for it. But today we focused on the term AI. So what is exactly we're referring to? Well, in today's context, in the context of now an understanding of how the brain works, when we looked at the brain, and we opened up the brain over the last 50, 60 years, what people found is not a CPU, not a central processing unit, and not like distinct memory areas. What they found actually is a distributed set of neurons. The average human brain has between 86 and 100 billion neurons and 100 trillion to 1,000 trillion connections, or synapses we call them. That architecture inspired the idea of these kinds of artificial neural networks. These biological neural networks translated to artificial neurons and artificial networks. And we train them similarly to how, again, a child might learn. We present many examples, and we have the network learn those examples. Initially, it's not going to be very good at doing good prediction and classification, but over time, with feedback, you can make it very good. And we had the move to deep learning, the idea that we can have not just an input layer, an output layer, and one layer in between, that's called the hidden layer, but actually we can have thousands and maybe even millions of internal layers. And that's the advent of deep learning that came with the GPU, this chip that we talked about. So AI basically is neuroscience-inspired architectures. It's a different way of coding. It's not coding with if this, then that. If something has four wheels, then maybe it's a car. We actually just present the cars and the buses to the neural network, and then it learns the nature of what it means to be a car, what it means to be a bus. We don't actually specify the rules in there. And so that became a very powerful architecture that now we actually have the LLMs, but LLMs are just the beginning, Francois, just the tip of the iceberg in terms of where we're going with AI. But now let's turn to quantum. Quantum says that the world that we know about, the world of billiard balls, of sending rockets to space, this is the world of Isaac Newton. This is the world that 300 years ago, Isaac Newton gave us the sense of how things will move, how things will roll down hills. If we drop, a feather and a big bowling ball, what will happen? This is all the world of Isaac Newton. But when we get to the microscopic, when we get to the world of atoms and electrons, we have to have a new kind of way of describing these. In fact, in 1899, a crisis occurred because the electron was discovered. J.J. Thomson got the Nobel Prize because he discovered the electron. And obviously, then the atom was not the smallest thing. And it turns out electrons do not follow the laws of Isaac Newton. And we need a new set of laws. And so Max Planck and Albert Einstein and Niels Bohr and Schrödinger and Dirac and many others came up with a set of laws and rules that says this is actually the way the world works fundamentally, and that's quantum physics. And so quantum is a language. It's the language that molecules use when they speak to each other, when they connect to each other. That's the world of quantum. Now, you asked about putting these two together. So when we think about putting these two together, that's a very powerful combination of computing. On the one hand, we have AI that's very good when you have a lot of data, and we can train on that data. And so we give a lot of the data. If we have, for example, 1 million patient records, and we say, what happens if somebody enters the hospital with chest pain? What are the likely outcomes? We can train an AI on that, and we can make predictions because we have 1 million points of data. But what if we want to have a new molecule, a new device, a new material? We don't have any data. It's novel. And that's when we have to use physics itself to figure out and make new data. We call that synthetic data, data that we create ourselves. And that data we can then apply AI to. So the next wave of AI is beyond LLMs, beyond the graphics tools and image creators and video creators, is this fundamental deep tech revolution of the combination of the best of AI and the best of quantum. And these two together are very powerful to help design a new world that meets many of our challenges in society.
That's fascinating. Coming back to Sandbox, where do you see the application of this technology, and what are the low-hanging fruit you are going to focus on right now?
Well, good question. So I think there's a few areas of low-hanging fruit immediately. First is simulation optimization. So here again, we have the opportunity to go after new drugs. Again, we're not a drug maker ourselves at SandboxAQ, but we can help drug makers. We can help pharmaceutical companies and drive their productivity and drive their acceleration. Right now, it takes on average 13 years to develop one drug. It takes on average €2.5 billion to develop one drug. And even after all that time and money, 80% failure rate in the clinical trials, Francois. 80% failure. That's a lot of money lost and a lot of patients who go without a medicine. So this is now a fundamental change in how we can get things done. AI and quantum coming together can say, okay, biotech company, okay, pharmaceutical company, you have an idea for a new drug. We can run it through millions of simulations way before it ever gets to the first human. And that is a very, very exciting
So the time to market.
Time to market is shrunk. Money goes down, the capital goes down, and that means we can go after more conditions. That means that rare diseases, means that, extending life and longevity is another great area. So that's one low-hanging fruit area. Clean tech is another wonderful area where we want to have new kinds of solar panels. Solar panels have come down in price, but there's another way to bring it down even another 90%, and that's called perovskites, a chemistry that is really gaining good momentum in terms of its efficiency, its level of converting sunlight to electricity, but it's not stable on a roof for more than about a year or two. And so using AI and quantum, we can change that game. We can actually make it last, hopefully, for many more years. So be it clean tech, be it biotech, there's a lot of different things that we can do there. So that's one area of S&O. But now, call it simulation optimization. But now let's talk about cybersecurity. as much as we love AI and quantum, and it gives us many positive things, let's also recognize, Francois, that there's attacks on cybersecurity, both from AI and quantum. And what do we mean by that? Well, if I have password files in a large company and the adversary, the hacker, has AI, they can do analysis of those password files and find patterns to maybe find a default password that was issued by the IT organization. That gives them an into the company. That's using AI as an attack tool. Quantum also could be used over the next number of years as an attack tool because the fundamental nature of cybersecurity, of how we communicate over the internet, of how we exchange credit cards, how we do bank transactions, the global economy is built on public key encryption, public key cryptography, the way that we can exchange information over large distances over the public internet. Quantum, as it scales into larger computers that are fault tolerant, breaks this cryptography. And so both AI and quantum, very positive technologies, but also means that we must upgrade our cybersecurity. And so that's the second area that we must address with AI and quantum. We must have better cybersecurity tools, particularly in encryption.
Tell us about the third pillar, which is sensing, and how quantum will change dramatically the way we sense, we acquire information.
Well, sensing the world around us is critical. And so be it medical diagnostics or be it other kinds of sensing, this is fundamental to modern technology. And so when we look, for example, at the challenge of GPS jamming, so all of us now are addicted to GPS. Imagine getting into a car and not having GPS, a map available, Google Maps, Apple Maps, any of the maps out there. Most people would literally be lost, literally be lost. But in fact, actually, we now see that more and more. We see that adversaries around the world, Francois, are jamming GPS. It's actually not that hard to jam GPS. It's a known published frequency, so of course we can jam it. People can jam it. And so be it in airplanes, recently, 2 passenger jets full of passengers from Qantas Airlines on March 14th of this year, the GPS was jammed. They lost GPS for hours and hours. More recently, just a month ago, quite a number of planes in the Middle East were jammed. They lost GPS. In fact, it was even worse then, Francois. In that particular case, some were GPS jammed, some were GPS spoofed, where a wrong signal of GPS was pushed into the airplane traveling at 800-900 kilometers an hour. That is a very dangerous scenario. And so we have to have a way of navigating around the world without GPS. In fact, that's what quantum sensing and AI together can give us. We can have a quantum sensor that senses the magnetic field of the Earth. That magnetic field is unique on every spot across the Earth. And then combine with AI to pull the signal from that sensor. We need the AI there. We can actually have a device and have built a device that is now flying on quite a number of government and private planes that actually can navigate without GPS.
Also for heart disease.
Well, exactly. The same technology I just mentioned for navigation can also be used to improve our cardiac diagnostics. Heart disease, Francois, as you well know, is the #1 killer in many countries in the world. And so how do we improve outcomes for heart disease? #1 is diagnostics. Right now we have ECG, we have ultrasound, there's a variety of initial diagnostics when someone has chest pain, but they don't give us enough information. In fact, in most cases in hospitals around the world, you have to wait for 2+ hours to get a particular blood test to see, is the heart, did it have some muscle breakdown, right? Some attack on the heart. And in fact, what can we do in the first 5-10 minutes? We can do not an ECG, electrocardiography, with the new advent of what we've developed with AI and quantum sensors together. We can have MCG, magnetocardiography. This detects not the electric field of the heart, but the magnetic field of the heart. And this is going to be a breakthrough for cardiac diagnostics.
Absolutely, and proactive medicine is one of the key.
We want to go to preventative rather than just reactive. Exactly.
Jack, to finish, we talk about lots of Gen AI. We've all tested that. What is your view? Is it a revolution? Is it an evolution?
Well, generative AI, I think, is a very powerful tool, particularly for certain kinds of applications. If you have a content application and you want to generate a lot of content, let's say you're a bank and you want to create a lot of research reports, Gen AI, I think, could create the first draft of that report. and do 70% of the work, let's say, with the human coming in to finish off the 30% and polish it. I know a number of screenwriters in Hollywood that are using Gen AI right now to become much more productive writers, and they're writing for multiple shows at the same time. So I think Gen AI is a very powerful tool that has many interesting applications. But Francois, really it's just the beginning of applications of AI. When we think about all the areas in terms of applying AI to many other fields beyond just content generation, this is where other forms of AI will really start rising. We are just at the beginning of this phase of the AI revolution, in particular by combining AI with simulation, AI with quantum. This is going to be a very powerful combination of both AI tools that can train on past data and simulation tools that can drive to the future. This combination is going to really revolutionize the whole world.
In fact, quantum will bring new signals, very weak signals, and AI will bring correlation between those signals to move forward the research.
Correct. Absolutely correct.
Jack, last question. What is your ambition and vision for Sandbox? Because I'm very excited when I listen to you. Where do you see yourself in 3 to 5 years from now?
Well, SandboxAQ has already grown very significantly. I'm very proud of all of our teams, Francois. Our teams have really excelled beyond any milestone that we internally set, be it in simulation, for drug discovery and battery technology and other areas, be it in cybersecurity to protect the world's data, a very key mission for us, or be it in quantum sensing. Our mission at SandboxAQ is to be the most impactful company in the world. And we define impact in terms of the positive effect we can have on all these different areas using frontier computing, using frontier technology. Key to that is our teams. So the first answer I would give to you about where do we see ourselves in 3 to 5 years, we see ourselves building on the A team that we have already hired, and A players hire other A players. And so we depend on the wonderful, incredible teams that we have to bring in additional people, internal to the company, but also, Francois, key to the next 3 to 5 years for SandboxAQ is partnership. We are already having a number of partners now around the world, here in France, in the UK, in the US, in Canada, and we're going to have more and more partners because we cannot do this ourselves. We have to partner with large companies and startups and NGOs and many others, and governments in many cases, to make sure that we can have the impact we want to on these critical areas.
Jack, thank you for sharing your passion and vision. I've got a great idea for you for Christmas.
Yes.
Jack's book, Quantum Computing and Applied Resource.
It's a very light read, Francois,
Yeah.
very light.
Yeah. I just read 10 pages each because after I need to understand.
Exactly, yes.
So thank you so much, Jack, for
Great to be
joining
here.
us.
Merci.
And congratulations for what you've accomplished in close to a year and a half.
Thank you, Francois.
Les amis, merci beaucoup pour votre attention. J'espère que vous avez été fascinés ou intéressés comme je l'ai été à écouter Jack Hidary. C'est la fin de cette conversation. À bientôt. Au revoir.